All right, in this last video for the week, we are going to graph y equals 2 secant of 3x over a 1-period cycle. And this is how you might see problems in the book written over a 1-period cycle. I'm just going to fill up the whole graph because once you've established the correct scale and everything else, there's no reason why you shouldn't fill out the entire graph. Okay, so again, just like we did with cosecant, I'm not going to think of secant here. I'm going to think of cosine of 3x. And from here, I can establish what my amplitude is. My amplitude is 2. My period is 2 pi over b, which in this case is 2 pi over 3. And then phase shift, again, I don't have a phase shift really in this problem, but you can imagine what it'd be like if you did. I'm going to use my period, dividing it into 4 equal parts, gives me 2 pi over 12, or pi over 6. Now if I had a phase shift and it were pi over 4, then I wouldn't want to use this as my scale. If it was pi over 3, this would be okay as my scale. If it were pi over 4, then I would want to make pi over 12 my scale, because 4 goes into 12 and 6 goes into 12. And so we would have 12ths as the appropriate scale. As you can see here, 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. And so pi over 12 would work with both of those, both the period and the phase shift. But in this case, here's my scale. This is the distance between my key points. This last time, between key points. And since that's my scale, it makes things a lot easier. We're just, we're going up 0, down 0, up 0, down 0. In this case, since it's cosine, we're starting at 1, so we're up, or we're starting at 2 because of the amplitude, and then going 0, -2, 0, 2. But let's go ahead and graph this one up. Okay, this was our cosecant graph that we did before, but now we're graphing secant. So the graph is actually y equals 2 secant of 3x, and I'm going to start by graphing 2 cosine of 3x. And we said pi over 6 was a good scale, so I'm going to count up by pi over 6's. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and 8 pi over 6 is 4 pi over 3. All right. Do the same thing in the negative direction. Negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, it's negative 2 pi over 3, negative 5 pi over 6, negative 6 pi over 6, negative 7 pi over 6, and negative 8 pi over 6 gives me negative 4 pi over 3. Okay, our amplitude is 2, so I'm going to label this as 2, and this one's going to be negative 2 down here. Now cosine normally starts at 1 at 0, and so we're going to start at 2 here. And from there, we are going to go down to 0, and then down to negative 2, back to 0, up to negative 2, 0, negative 2, 0, 2. Okay, and you can see I complete one complete cycle in a span of 2 pi over 3, which was our period. And again, if I were doing this with you in person, I would be doing this in pencil, because I'm going to erase it after I have figured out what secant would actually look like. So here's my cosine graph. Okay. Everywhere that cosine equals 2 or -2, those are points on my actual secant graph. And anywhere where the cosine graph is equal to 0, my secant graph is going to have a vertical asymptote. Maybe everyone can treat this opportunity as sort of like a coloring exercise. They say, they have those coloring books for adults now that help reduce stress. Let's think of graphing sine and cosine, secant and cosecant as a stress reducer, okay? So I'm going to draw my parabola-looking things in here for my secant graph. Take your time. You can make a happy little secant graph there and a happy little secant graph there. Use the Bob Ross approach. Try to enjoy what you're doing. And then I'm going to go in here and I'm going to try to be a little bit better at erasing than I did before. But I have to tap the eraser every time. It automatically goes back to the pen. Alright, so I'm erasing the blue part because that is not actually the graph that I was here to graph. And so when I erase the blue part, I am left with my secant graph here. And just do the best you can. This actually works out better when you do it on paper because everything else was in pen, and I would just erase the pencil and you would just be left with what you wanted there to be. And so there is the graph of 2 secant of 3x. Try out the problem set for tonight. Make sure you have it submitted by the due date. I will not accept them late. Reach out with any questions that you have. Even if it's on the last problem set or problems that you're doing in the book, or confusions that you had when watching these videos. I know I made some mistakes labeling the axis on Tuesday's video. I can see how that might be confusing. Just go back, watch it again, try to ignore my my fumbles, and I'm here to help you if you need it. Please reach out. Okay, well, I will see you next week where we will talk about the inverse trig functions. We're not going to do that graphically. We're going to do it algebraically, which is nice. And then Thursday, I would like to have a Zoom meeting if we could.